So in this problem, we need to determine the equation of a circle that passes through the origin and it intersects the lines y equals to x and y equals to negative x, such that they're going to cut off equal chords of length a units from these lines. Fine. Well, we need to find out the equation of the circle. There is also a second part. We also need to determine the equation of the circle if the chord length is equals to square root of 2. So first we'll try to find out the equation of the circle by taking chord length equals to a, and once we have the result, we'll finally replace that value of a with square root of 2 to get the final result. So let's try to understand the problem graphically here. So we have the Cartesian plane with the x and the y-axis, and there are two lines. The line y equals to x is going to pass through the origin, and it's going to make an angle of 45 degree with the positive x-axis. Similarly, we have the other line with equation y equals to negative x-axis, negative x. That's also going to be a straight line that passes through the origin, and it's going to make an angle 45 degree with the negative x-axis as well. Now, our goal is to find out the equation of a circle which passes through the origin. So let's start with one circle first. So here we have the circle. It's touching the origin, or you can say it is passing through the origin. The two lines y equals to x and y equals to negative x, these two lines are forming two chords on the circle. As given here that the length of these two chords are going to be equal. So this has a length of a unit. Now, using this information, we need to find out the equation of a circle. As you can observe here, that the line y equals to x, it intersects the circle, let's say at this particular point A. Also, the other line y equals to negative x, it also intersects the circle at this point B, and they both cuts off equal chord of length a unit. So that means OA, the length of OA is equals to OB, and this is equals to a unit. Now, if we join AB, point AB, here angle AOB, here will be equals to 90 degree. That means the two lines are going to be perpendicular to each other. How is this possible? That's very simple, because the slope of the two lines, so if we consider the line y equals to x, so it has a slope m1 equals to 1. That's very simple. All we have to write it in the y equals to mx plus c, which is, that means in the slope intercept form. So this slope of this line is 1. And if we consider the line y equals to negative x plus 0, then the slope of this line will be equals to negative 1. Since the product of the two slopes is negative 1, we can say that the two lines must be perpendicular to each other, and hence angle AOB equals to 90 degree. Now, if angle AOB is 90 degree, then point A and point B, they must be, if we join it, it must pass through the center of the circle, and it should be the diameter of the circle as well. So that means our goal will be to find out the coordinate of point A and coordinate of point B, and once we have those coordinates, then we can use the diameter form of a circle to determine the equation of a circle. Right? So that's very easy. All we have to do is do a construction here. We're going to drop a perpendicular from point A to the x-axis. So let's call it AM, and from B as well, we're going to drop another perpendicular AN. So this is a construction that we're doing, with the construction being AM perpendicular to the x-axis. Similarly, we are also doing the construction BN perpendicular to the x-axis. Now let's consider the right angle triangle AMO, which is right angle at M. So if we find out tangent of angle AOM, so this will be equals to the perpendicular over the base, which is OM. Now, what is angle AOM? We have already mentioned that the line y equals to x always makes an angle 45 degree with the x-axis. So we have tangent of 45 degree equals to AM over OM. And we know that the tangent of 45 degree, that value is 1. So that means we have AM equals to OM. So this length will be exactly equals to this particular length. Fine. So now we have the length OA. So OA is given as a unit using Pythagoras theorem. So OA squared must be equals to OM squared plus AM squared. So that means OA squared, which is A squared, this must be equals to OM. So OM length will be exactly equals to AM. So we get 2 times AM squared. which will be equals to am squared, or finding the value of am will be square root of a over 2. So we've obtained the value of am, so that is a over square root of 2. Similarly, we can find out om because they're equal, so that's also a over square root of 2. Now we have the coordinates of point A. So the x coordinate is a over square root of 2 and the y coordinate is a over square root of 2. So that's the coordinate of point A. So let's note it down, a over square root of 2 comma a over square root of 2. Similarly, we can also find out the coordinate of point B. So all we can do is we can prove that BN length is going to be exactly equals to ON, because this angle is also 45 degree, and since OB, this length is a unit, so BN is going to be a over square root of 2 and ON is also going to be a over square root of 2. But since we're trying to find out the coordinate of B that's lying in the second quadrant, so coordinate of B is going to be the negative x coordinate, negative a over square root of 2, comma the y coordinate, that's positive a over square root of 2. So what we have here is now the coordinates of the endpoints of the diameter. So here we can use the fact that if we have a circle with a diameter, let's say AB, and the coordinates of the endpoints are given, if it is x1 comma y1 and x2 comma y2, the endpoint having these coordinates, the equation of the circle will be x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals to 0. Fine. Now what we can do, substitute the value of x1 with a over square root of 2, y1 with a over square root of 2, and x2 with negative a over square root of 2, and y2 with a over square root of 2. Then we're going to get x minus x1 times x minus x2, but x2 being a negative number, so we have x plus a over square root of 2. Added to y minus y1 times y minus a over square root of 2 equals to 0. So this is going to be the equation of a circle. If you want, you can expand it, but I'm going to keep it in this particular fashion. But this is the equation of only one circle that we have obtained. If we go back to a diagram, there are in fact actually 3 more circles that are possible. So let's try to sketch all of them. As we can see, there are 3 more circles. So we will need the coordinate points, and if we have the coordinate points, the endpoints of the diameter, then we can easily find out all the equation of the circle. So I'm leaving that as an exercise for you to give you the final result. The different equation of the circles are going to be, we'll have x plus a over square root of 2 whole multiplied to x plus a over square root of 2. Added to it will be y minus a over square root of 2 times y plus a over square root of 2 equals to 0. The equation of the third circle is going to be x plus a over square root of 2 multiplied to x minus a over square root of 2 plus y plus a over square root of 2 multiplied to y plus a over square root of 2 equals to 0. And then we have the equation of the fourth circle, so that's x minus a over square root of 2 multiplied to x plus a over square root of 2 plus y minus a over square root of 2 multiplied to y minus a over square root of 2 equals to 0. So we've finally obtained the equation of all the 4 circles. And finally, coming to the last part, if we replace the value of a with square root of 2, then we will get the desired result. So it's going to be a simple problem. So the equation will be, so I'll just write down the one of the circle. So that's going to be x minus, so we have square root of 2 over square root of 2, so it's going to be 1. So we have x minus 1 times x plus 1 plus y minus 1 times y minus 1 equals to 0.